Okay. Hello everyone. Let's start exit exam or gate exam questions for chemical engineering. Actually, in yesterday's class, we have started the main chemical engineering or the major chemical engineering courses which are given for exit exam or gate exam. Now today let us start the questions, which means that actually the courses we're going to give for this stages or for part one is chemical engineering thermodynamics, which is directly prepared by Leta. So the question says the fundamental principle of refrigeration is based on the A. Zero's law of thermodynamics, B. First law of thermodynamics, C. Second law of thermodynamics, D. Third law of thermodynamics. Before Before answering this question, let us start the explanations for the laws of thermodynamics. The first law of thermodynamics says Zero's law of thermodynamics, which states that if two thermodynamic systems are both in thermal equilibrium with a third system, then the two systems are in thermal equilibrium with each other. In thermal equilibrium with each other means actually the change in temperature with respect to time is constant. Let us consider the following system that indicates the fundamental principles of Zero's law of thermodynamics. If A is thermal equilibrium with B and B is in thermal equilibrium with C, then A is in thermal equilibrium with C. This is called as or known as or refers the Zero's law of thermodynamics, which is diagrammatically shown as follows. Two systems are said to be in thermal equilibrium if they are linked by a wall permeable only to heat and they do not change over time. The zeros law is important for the mathematical formulation of thermodynamics, which is a base for the other laws of thermodynamics. In other words, it makes the relation of thermal equilibrium between systems an equivalency relation, which means an equivalency relation means if two systems are in thermal equilibrium with the third systems, this is called as an equivalency relation. The zeros law is needed for the definition of such scales and justifies the use of practical thermometers. If a body C be in thermal equilibrium with two other bodies A and B, then A and B are in thermal equilibrium with one another. For example, or for instance, let us see initially the temperature of A was 15 degrees Celsius, but when permeable wall applied between A and B and C, then each system gets 5 degrees Celsius due to thermal equilibrium. This representation states that A and C both have the same temperature. That means they all are mutual thermal equilibrium. So this considers that A is 5 degrees Celsius, B is 5 degrees Celsius, C is also 5 degrees Celsius. Second law of thermodynamics, which is known as the first law of thermodynamics, states that the formulation of the law of conservation of energy in the context of thermodynamic processes in which two principal forms of energy transfer, which means that heat and thermodynamic work are distinguished, that modifies the thermodynamic system of a constant amount of matter. So this law indicates that the internal energy of the system is equal to the heat which is supplied to the system or the heat which is released from the system minus the work done on the system or by the system. The third one is the second law of thermodynamics, which establishes the concept of entropy as a physical properties of the thermodynamic system. This second law of thermodynamics explains the fundamental principles of refrigeration and it works on the principles of Carnot. So according to Carnot principle, the efficiency of the given system is directly equal to 1, which means that the Carnot principle applies for the highly efficient system. The second one is the second part contains the law of the increase in entropy. So the entropy, which means that the change in entropy is directly related with the change in temperature of the system. The fourth one is the third law of thermodynamics, which states that entropy of a perfect system at a temperature of 0 Kelvin or absolute zero is equal to 0. This indicates that or tells that T directly equal to 0, which means that dq by T might diverge. As F fails, the fourth law of thermodynamics is currently emerges, which states the dissipative component of evolution is in a direction of steepest entropy ascent. So based on these explanations, the answer of this question is the second law of thermodynamics, which applies the principles of the second law of thermodynamics. So thank you for your attention and don't forget to subscribe this video.